You know what a constant function is, like y equals 7, a linear function, y equals mx plus b, a quadratic function has x squared, cubic and quartic. So those names are names that you'll need to kind of have memorized, but I think you already know those names. Anything higher, you call it nth degree, like this is a 6th degree or 10th degree. And then you should know what a monomial, binomial, and trinomial is. So if I gave you an example of 2x, you would call that a linear monomial because there's only one term. That's considered one term. This would be considered a linear binomial because there are two separate terms, but it's x to the first power. This would be called a quadratic trinomial. So you're going to have to be able to name these polynomials. And I'm not going to be asking you this on a test because I'm talking about polynomials. So I really just put this on there in case you're taking the SAT. They might ask you the degree of a monomial. So like if you had 3xy cubed, that technically has a degree of 4. You add up all of the variable powers. So x to the first y cubed is a 4th degree. X squared y cubed would be a 5th degree. I'm not going to ask you this because these are not polynomials, right? A polynomial is y equals something. They're using y as a variable here. But just so you know, if you ever see this on like the SAT with multiple variable terms, like what if I had x squared z to the third y? What would be the degree of that? Right? That's not a function, but it's a bunch of variables being multiplied together. The total degree would be 6, right? X squared plus this 3 plus this 1 that's not really written. 2 plus 3 plus 1 is 6. More like SAT. So I won't be asking you that type of question because I'm focusing on these polynomial functions up here. This is kind of a review of some terms here. The zero of a polynomial means x-intercept or solution or root. And it says the zeros of a polynomial are just the x values that make the y value 0. They're similar to x-intercepts on the graph. If it can be factored, we already figured this out. The zeros just make the factors equal 0. A polynomial can have at maximum the same number 0 as the degree. So if you have a quadratic function, right? How many times might that cross the x-intercept? Once, twice. X squared could have 2 x-intercepts, but x squared could also have 0 x-intercepts, and x squared might only have 1 x-intercept if it just bounces off. So this rule says a polynomial can have at maximum the same number of zeros as the degree. X squared could have 2. How many could x to the first have? How many x-intercepts can a linear function have? It can have 1, right? How many times is that going to cross the x-axis? Once. What about x cubed? How many x-intercepts could x cubed have? It could actually have 3. Boom, boom, boom. See how I crossed it 1, 2, 3 times? But it might not have 3. So if you think about this function, this is also x cubed. It only had 1 x-intercept. So it doesn't tell you how many it has. It just tells you like this couldn't have 4 x-intercepts. This guy couldn't have 3 x-intercepts. So this says let's factor this quadratic and find the zeros and then sketch the graph. How do I factor this? So what are the factors of -12 that would add up to 4? So straight off the quiz, how would I factor that? I put an x in each. Yep, +6 times -2. Right, that multiplies to give you the -12. What are the 2 x-intercepts then? Yeah, -6 or +2. They're the opposite of what goes inside there. So if you wanted to sketch a graph, you would plot -6 and 2. And you could find the vertex. I'm not gonna find the vertex right now, but I know it's concave up because it's 1x squared. So I can use the 2 x-intercepts to sketch the graph of the quadratic. Here's something you should have heard about in Algebra 2. It's called multiplicity of a zero. I think it was probably touched on at the end of Algebra 2, so you might have forgotten it. And it basically affects what's going on the x-axis. So it says in factored form, the multiplicity of the zero is the degree of the factor. What was the degree of each of these factors? This was to the first power right here, right? And this was also to the first power. There was no other power outside. See in this next example, this has a power of 2, right? So that's the multiplicity, is what number is showing up here in the exponent. That's your multiplicity of 1 or multiplicity of 2, or if it was cubed. It's going to change what happens on the graph. So this says this is this has an x-intercept of 0 and an x-intercept at 5. I want you to look at this graph and see if you can figure out what's happening at these 2 x-intercepts. What is it? X times x minus 5 squared. I just said there's going to be an x-intercept at 0 and there's an x-intercept at 5 because the function was x times x minus 5 squared. How is this x-intercept different than this x-intercept? The graph is going like this, up here and then like this. Do you see a difference in what's happening at those 2 x-intercepts? What's happening at this x-intercept? It's cutting through the axis, right? What happens at this x-intercept? It bounces off. It never actually goes below. Doesn't this kind of look like a quadratic, x minus 5 squared? So this 2 is actually kind of creating a quadratic right here on that part of the graph. It's bouncing off. What's happening here? Doesn't that kind of look like a linear function right here? If I just look at this section of the graph and this section of the graph, so this is going to tell you what's happening at that section of the graph. Does it behave like a linear function or a quadratic? So if it is odd, see this one right here is odd, we say that it cuts through the axis. This number right here is even, the 2 is, so we say it bounces off the axis. So we're going to look at some of those examples. What does the equation tell you about the graph that you might not be able to look at? So you can star this part right here. Even in odd multiplicity, the graph will cross the x-axis, right, when it's odd, and it'll bounce off the x-axis when it's even. Odd cuts through, and even bounces off. I'm kind of reading through the rules, and then I'll help you kind of apply these and practice them, but we haven't heard some of these rules and definitions in 2 years, some of you. Then there's this last piece here. You spent a whole exploration graphing functions and coming up with these rules in Algebra 2, but the leading coefficient, that's the number in front of the function, it tells you what the right side of the graph is going to do. So if the leading coefficient is positive, the right side goes up. If the leading coefficient is negative, the right side will go down. What's a leading coefficient? Leading coefficient is what number comes first. What's the leading coefficient right here? A 1. Is that positive or negative? That's positive. So I'm not sure what this graph looks like yet, but the 1 tells me that the right side of the graph points up. I know this is a quadratic, so I know both sides of the graph point up. But it tells you what the right side of the graph does. And then if the degree is even, the left side goes the same. If the degree is odd, the left side goes opposite. So you can always tell if you're looking at a quadratic, both sides of the graph go up. You know that you're looking at a cubic if one side goes up and one side goes down, right? That's not a quadratic function. They're going in opposite directions. So we're going to analyze these different equations. This last rule is about the number of turning points. I don't even like to think about this rule. I just think about functions I know. How many turning points are on a quadratic? So if x squared, it only has one turning point, right? Down there at the bottom. How many turning points on a cubic function? It might have 2, right? So x cubed has 2. See how that's 1 less than the degree? So it says whatever degree you have, you could have n minus 1 turning points. So what they want you to identify in these two problems, what is the degree of this function? The degree is the biggest exponent, right? So degree is 10. So how many turning points could there be? There could be 9. There probably isn't, because that graph would like have to look like this, right? So there'd be 9 turning points. Right? Most graphs kind of take a couple turns and that's it. There could be 9, but there probably isn't. What's the degree of that next function? So you find the highest exponent. The highest exponent is x cubed. So if the degree is 3, the number of turning points could only be 2 or fewer. So that's a lot of rules. So these are the types of questions you might, see. We'll kind of go through and practice them together, because at the end, and this is probably like tomorrow, there's a polynomial practice page 115 that'll help us put all this stuff together. This is kind of relearning a bunch of definitions. So let's go back to the beginning. This just says identify, is it a polynomial or not? And I'll tell you, there's only one in this whole section that fails the test for the polynomial. So what are the rules? You want to have real coefficients, which just means you can put it on a number line. Even 1.7 is a real number. Or the square root of 2 is a real number, right? It's 1.4 irrational. So we're looking for real numbers, and we're looking for whole exponents. So can you find one of those that fails that test? Yeah. Why does D fail? Right, so it says if it is, write it in standard form. So this is just not a polynomial, right? X to the 1/2 power, that doesn't work. It has to be x squared, x cubed, x to the 4th. All right, let's go back to part A. First, I have to write it in standard form. So I have to write the highest to the lowest. 2x cubed has to come first because x cubed is the highest. What's the next highest? 2x squared. So I write plus 2x squared. So I'm just going to kind of cross them off. What's the next highest power? The pi x. Pi is a real number. 3.14, it just is irrational. So I'm going to write minus pi x. And then I put my constant plus 4 last. So now it's written in standard form. Now I'm going to look at this term that's in the front. That's going to tell me my degree and my leading coefficient. So what is my degree? My degree is the highest exponent. So my degree of this whole function, this is a cubic function, and my leading coefficient is the number that comes first in standard form. So my leading coefficient is positive 2. See if you can do B and C. And then that's probably where we're going to stop. We'll catch up here after lunch. But see if you can rewrite B and C in standard form for a minute before the bell rings. Degree and the leading coefficient. So you should have said for part B, f of x, that just means y equals. So you can either write f of x or y equals. Negative 2x to the 9th is the biggest, right? Negative 2x to the 9th. Then I would have this one, negative 3x to the 7th. Then I would have plus 2x and then plus 4. As I look at my exponents, I went 9, then 7, then 1, and then this is a constant number. So I look now at the very front of this equation. There's my degree. The highest exponent power is 9. And my leading coefficient is the number that's in front of that whole equation is negative 2. All right, and then hopefully you had time to write out C in standard form. It looks like the highest power is this 1/2 x cubed. The next highest power is this 2x squared. Then this negative root 3, which is like negative 1.7 times x. The x can't be under the radical. So the x is in parentheses outside of the radical. So that's okay. Negative root 3 times x, and then plus 4 goes on the end because it's a constant. So look at this first term here. The total degree would be 3, and my leading coefficient would be 1/2. So could you do those two things? So if I gave you a question, could you say, is this a polynomial? And can you write it in standard form, state the degree, and state the leading coefficient? So could you try example 2? Determine if it's a polynomial, state the degree, or say why it is not a polynomial. So see if you can go through and do that for example 2 for just a minute. Would those be polynomials? And what would their degree have to be? There's only one of them that fails. Which one fails? B fails, right? Because you can't have an x in the denominator. So I'm going to say x in the denominator. We haven't really studied anything more than that this year, but this technically is x to the negative first power. It's an exponent rule that takes the reciprocal. So technically you have a negative exponent, but I'm just going to say x in denominator, so it fails. So part A, this is just a linear function. So what is its degree? Its degree would be x to the first power. Part C is a little bit tricky. That is a polynomial, right? That's a quadratic function that's in factored form. So even though this looks like it's an x and this looks like it's just an x, you really have x squared here when you multiply that out, right? If you put it into multiplied out standard form, you really have x squared minus x when you distribute. So its degree is actually 2, and a lot of students overlook that. But this is not a linear function, right? X times x is x squared. So when it's just in standard form, it's that leading degree. All right, number 3, we've already practiced this because we've already learned how to factor. They want you to find the 0 first. What is the x-intercept? And then we'll talk about the multiplicity. But what would the x-intercept have to be to make this function equal to 0? So x would either have to be what or what? Yeah, 0 or positive 5, just like you would do after you factor the problem. Now it says, what is the multiplicity of each one? So for multiplicity, you look up here. What was the power of each of these factors? It was an unwritten 1, right? So if you have odd multiplicity, what happens on the graph? You cut through at both of them, right? They both have odd multiplicity. So you're going to cut through the axis at both of them. Let me just show you an example. X times x minus 5. If I put it in, see how it cuts through at 0 and it cuts through at 5? So it cut through the axis at both of those x-intercepts. What about in part B? What is the x-intercept here and what is the x-intercept here? So what would make this factor 0 and what would make this factor 0? What are your two x-intercepts? 0 and positive 3. So I'm going to say 0 or 3. But what's different about the multiplicity this time? This one has a 1 that's just not written there, x to the first power. But what does this factor have? It has a 2 right there. That's the multiplicity. So what's going to happen at this factor? At 3, it's going to bounce off the x-axis. So this will be my cut through and this will be my bounce because my multiplicity is even. right? Multiplicity is even, odd, 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 right? It's based on what that power is. So let me just show you the difference in the graph. If you have x times x minus 3 squared, we are expecting the graph to bounce off at 3. So see how it cut through at 0 and it bounced off right there at 3? That's because of the multiplicity. Why is C different? What's different about A and B and C is written differently? What's different about C? Right, these are already factored. This isn't factored yet, right? So I need to actually do the greatest common factor before I can read the multiplicity. So good practice. What would be my greatest common factor to factor this one? What can I pull out of both constants, 5 and 20? I can pull out a 5 and I can pull out an x. All right, so what do I have left? I would have x squared here. And then what happens when I take negative 20x and divide by 5x? Minus 4, I think. Can that go one step further? Like your eyes should kind of like, oh, here we go. This is something else, right? This is a difference of squares. X squared minus 4 factors into x plus 2 and x minus 2. You don't have to do the diamond method because that's just a difference of squares problem. How many factors do I have now? I have 3 separate factors for this cubic function. So I'm going to have 3 separate x-intercepts. Each has a multiplicity of 1, right? So what are my 3 x-intercepts? X is equal to, what would make 5x 0? 0. What would make x plus 2 0? Negative 2. And what would make x minus 2 0? Positive 2. And because they all have a first power, they all have odd multiplicity cut through. Let's see, what would this look like? 5x cubed minus 20x. I can type it in factored or unfactored form. So it cut through at negative 3, at 0, and at 3. So it went up, down, and up. So it cut through at each of those x-intercepts. I'm going to skip number 4 for now because it'll blow you away with the algebra. Let's go over to number 5. We'll go back to 4 tomorrow, I think. All right, on these, it says find the x-intercepts and the multiplicity and sketch the graph. I'll show you how to sketch the graph in a minute. I want you to find what the x-intercepts are and what the multiplicity is. Are they even or odd? Right? They're already in factored form. You look at the parentheses and you decide, oh, this x-intercept is 10, or this x-intercept is 1/2. So for each of these, write down what are your x-intercepts. Right? Look at this, look at this. That should be quick. Don't have to do really any work. Yep, after this problem, sure. You should have said 0 or 1, right? 0 from the x squared. If you plug in 0, you get 0. 1 from the x minus 1. If you plug in 1, you get 0, right? What is their multiplicity? What is the exponent up here? It's a 2, right? So this has a multiplicity of 2, and this guy only has a multiplicity of 1. So that's even. It's going to bounce. This one's odd, so it's going to cut through. So I'm going to draw a graph that has all that information and all that information on there. So here's my x-axis. I'm going to plot 0, 0, and over here I'm going to plot 1, 0. Those are my 2 x-intercepts. I also need to think about the end behavior of the graph, but what's the leading coefficient? Way in front of this x squared, it's a positive 1. So that tells me on the right side of the graph, I don't know anything else, but I know that this has to point up because the leading coefficient is positive. What's the total degree of this function? If I was going to multiply everything together, x squared times x gives you x cubed, right? The degree is 3. So that tells you that the left side of the graph has to go in the opposite direction, right? Cubic functions look like this. Quadratic functions both up or both down. So this is one arm up and one arm down. Which of these do I bounce off of? This says I have to bounce at 0, right? So I'm going to bounce at 0, come down, and then I'm going to cut back through at 1. So see how I just put all that information together? I never looked at a graph. I made the graph myself, knowing the x-intercepts, their multiplicity, and the end behavior of the graph. Yep. I'm putting this back up because I think my video was paused. So we're taking a guess of what the right and left side is going to do on one of these graphs. So my eye is drawn to it being positive or negative. This one was positive, this one was negative, and this one was positive, right? So if it's positive, it goes up, and if it was negative, it goes down. That's the right side of the graph only. Once you figure out what the right side is doing, you decide if the left should go in the same direction or opposite. So you look at the degree. X to the 5th is odd, odd opposite. So if this was up, then this would be down, up, down, opposite. This again is odd, right? X cubed is odd. So down, up would be opposite. X to the 10th is even, like a quadratic. So they're going to go in the same direction. They'll go up, up. So that you're going to need to know that end behavior rule. And if you don't know the end behavior rule, think of your friend, the quadratic, right? A quadratic, 3x squared, both ends go up. Negative 3x squared, both ends go down, right? So if it's positive, 3x cubed, that tells you it's up on the right, but down on the left because they're going opposite. So use that leading coefficient from the quadratic to help you, so it's not something else you have to memorize. All right, give me an example. So look at 7, using end behavior only. If you had an even degree and a positive leading coefficient, what might you look like? This should not say the word turning point here. And then if you had an odd degree and a negative coefficient, what might you look like? So draw me like a squiggle. Like this would be a squiggle graph. Like would that fit that qualification, or might it look like that, right? Based on the degree and the leading coefficient, what can you predict? Like what could it look like? There's a lot of right answers for number 7. And I know it's a lot of new, so that's why homework 1-6 is not due till Wednesday, because we need tomorrow to keep kind of processing through it. This is just kind of remembering some of these. You had to go down on the right? Down on the right. The degree is odd, so they have to go in opposite directions. You could also just do simply a linear function, one up, one down. But if it's negative, it goes down on the right-hand side of the graph. So kind of refreshing those end behavior rules, but thinking about like a regular quadratic. What did we say about turning points on the front page? And if you forget the rule, I always think of a quadratic. A quadratic is x squared. How many turning points does it have? Only one. So the degree and the turning points, what's the relationship between them? One less. Don't memorize the rule. Just memorize, oh, for a quadratic, right, it's one less. All of these are going to be one less. They all follow that same rule. So if I have a linear function, How many turning points does a linear function have? It has 0 turning points, right? A degree of 1, it never changes direction. So go through on B, C, and D. Make sure you think about standard form and see if you can predict how many turning points could that graph have. How many turning points? And then justify to yourself why. Like, I'm not just guessing the number 4. I see this number, I know the answer is 4 or 2, right? Because if I asked you to justify on the test, I'll give you like 20 more seconds to think about which one it would be. Who can tell me the answer for 8B? 2. Why is it 2? I'm looking at any of these cubic terms here. Those would be the biggest term. X cubed can have 2 turning points. It might not have 2, but the maximum it could have is 2. So now on part C, I'm going to look at the x squared term because that one happens to be the biggest. So one less than that would have 1 turning point, a quadratic. And then careful on part D, x to the 6th is over here. It's just not written in standard form. So that could have 5 turning points. All right, write for me an equation of a polynomial that has a maximum of 4 turning points, like y equals. What could the equation be? It has to be a polynomial, maximum of 4 turning points. And then I'll show you 9 and 10 how to do them by hand and maybe with a calculator so that if you had a calculator, you could use it. And that's probably where we stop. Oh, made it almost to the end. What power do I have to have for part E? 4 turning points has to have a power of 5 at least. So like x to the 5th plus 2x cubed plus, I don't know, 3x, something like that. That's x to the 5th, so it could have 4 turning points. So any function that has x to the 5th as the highest. All right, so here is a good test question for Friday because number 9 and 10 require you to do a lot of different pieces of information. What's the difference between 9 and 10? This is called factored form. This is called unfactored form. So the way that I approach these is going to be a little bit different. But if you had this question on your test on Friday, could you find x and y intercepts, state the multiplicity, decide what degree it is, that's what a power function is, how many turning points could it have, and then we're going to graph it. So first of all, what are my x-intercepts? I can tell because I'm in factored form, right? So what are my 3 x-intercepts? X equals what, and what? Does everybody else see that? Like in factored form, are you registering that those are the x-intercepts now, hopefully? Like 0 from this one, +1, and -3. Because to me, that's a big idea of quadratics. Most of you had that part good on your quiz. So let's plot those. Here's 0, here's 1, and here's -3. Well, guess what? I already found my y-intercept because 0, 0 happens to also be a y-intercept. If I didn't have the y-intercept, I could plug in 0 into my function and calculate it out, but I don't have to do that. Tell me about the degree of this function. If I multiplied this out, what is x squared times x times x? X to the, yeah, x squared times a factor of x times a factor of x is x to the 4th, isn't it? So my degree would be 4. So tell me about the end behavior. I've got these 3 dots sitting in space. I need to make a graph out of this. What's going to happen on the right-hand side? So I look, it's going to what? Go up. The leading coefficient is +1 right there. So I know I'm going up on the right. This is x to the 4th as my total degree. So left is also going to go up. Do you see how that's an up function? Now I need to figure out kind of the squiggles that are in the middle. I see an x squared term. This factor is only the first power, and this factor is only the first power. So these are both cut-throughs, and x squared is going to bounce off, right, at that x-intercept. So I'm going to cut through here, come up and bounce off here. It's going to be kind of like a W. I don't exactly know where these turning points are, but that's my W-shaped graph, right? Cut through, bounce off, and cut through. So that's hard. That's a lot of facts to kind of keep straight. The x-intercept part should be easy when it's in factored form and plotting those, but then you need to know what is the degree, x to the 4th. What does that mean for the end behavior, up, right? And then cutting through, bouncing off. That's a lot of stuff to put together in one question. So I would lead you through it, like part A, part B, part C. So let's see, there's one more I wanted to do. What time are we here till 57? Okay, let's do number 10. This is not in standard form and it's not factored. So I need to be able to figure out the x-intercepts for this one. So let's first put it in, actually I don't even need it in standard form. How can I factor out a greatest common factor? What can I divide out of each one? X. Let's divide out an x. What will I have left if I divide by x? X divided by x is 1. What's x cubed divided by x? X squared. This is not usually the way that you see difference of squares, but would you agree that this is a difference of squares? 1 is a perfect square, and x squared is a perfect square. So I can factor this using difference of squares in this order. It doesn't matter. So this would really be x, 1 minus x, and 1 plus x. So I hope, even if you don't know how to do the other types of factoring, we've seen about 4 difference of squares today. Maybe that one's starting to be familiar to you. What are my 3 x-intercepts? What, and what? So this should be popping right out of you. X has to be 0 here, 1 here, and -1 here, right? Because it's whatever makes it 0. 0 or 1 or -1. So plot those on your x-axis. Those are your x-intercepts. I don't have to find a y-intercept because my x-intercept and my y-intercept are both at 0. If I had to find the y-intercept, I could plug 0 into the original equation. Go back to this standard form. If I put this in standard form, it would have been -x cubed plus x. What does that tell me about the right side of the graph? -x cubed. Negative leading coefficient. Down, right? Negative. So on the right side of the graph, I need to go down because I have a -x cubed. What about on the left side of the graph? I have x cubed. That's a cubic function. What do those do? One goes up and one goes opposite. Down, up on the left. What do I do in the middle? Am I going to be bouncing off anywhere? Am I cutting through? I look at these factors, right? This is x to the 1st. This factor is to the 1st, and this factor is to the 1st. Odd, odd, odd. So it's going to be a cut through, and cut through to connect it.